All right. Today is episode 2, the Bay of Monsters, right? On Jimmy's Quest, right? If you all notice, my voice is horrible. All right, so you all can read the storyline here. Right? As you all remember from last week, Jimmy saved Lord Ritter's life by knocking Gum Gum off the cliff, right? So all right, so the whole premise of this story is that there's something called beast crystals that are used to control monsters and whatnot around the kingdom and whatnot. And of course, as we go on, you'll get more explanations and whatnot. All right, so here's what you don't really need to just now for this one here. I won't make you all draw the diagram for it because it's a graph, right? What I need for you all to do is answer the questions. Now, remember last week there were two different types of graphs. There was a distance time graph and a speed time graph. Now, in this first question today, it's a distance time graph. But you all will notice I'm playing a slight trick on you. The x-axis is in minutes. And if you read the question, they are asking you for the answer in hours. Anyway, give it a try and say, do not overthink this question, right? It's way more common sense than maths. Good luck and send the answer across on the chat. All right, so answers are coming up. Now, the distance is being measured, but the experiment or race started at point A. So this graph is representing the distance of both objects. And there's one object represented by a red graph and another object represented by a blue graph. And the graphs are measuring the distance from point A at the beginning of the race. Now, for two things to meet, they must have what? The same distance. Like if you and someone else is running a race, the only time that you all will meet is when you all are the same distance from the starting point. You all will notice that the graph meets over here. Let me get a different color here. Notice that the graph meets over here. And over here, if you measure the y values for both the red and the blue graph, apparently the distance of both of them at the same time is 6 kilometers. Now, I know the 6 kilometers is kind of hard to see, but the point is the two graphs meet over here, meaning that the y coordinate, which is the distance, is the same. So in other words, the circle is where both objects meet. And they are asking how long. So they're asking for the answer in time. Now, if you look carefully, right, you will see that it falls smack in the middle. It falls smack in the middle of 60 and 80. So that means it's how much? 70 or how much? Minutes. Everyone agree with me at least that that is how long it took for both objects to come in contact with each other. But here's the thing. They don't want the answer in minutes. They want the answer in hours. Now, a lot of people said 70 minutes is the same thing as 1 hour and 10 minutes. But they didn't ask for the answer for peace to be in hours and for peace to be in minutes. They want the full answer to be in hours. So how much minutes are in an hour? 60 minutes. So if you take 70 and divide it by 60, won't you get 1 and 1/6 hours? I know some people would have put it as a decimal, right? But I would prefer the 1 and 1/6 because if you use 1/6, there's no rounded off now. And I know some examiners can be picky. You see, whenever you get a fraction that's a reoccurring number, it's better to use the fraction. All right? All right. So this is the preferred answer. 1 and 1/6 hours. Refrain from using the 1 hour and 10 minutes because of the instructions the examiner gave us. All right, so let's move on to the next part of the question. Right? Same graph, except a different question now. What is the speed of the object? Now look at this, in kilometers per hour, right? Between A and B. Now, this is my advice, guys. My advice is the y-axis is already in kilometers. So that is good news. But the x-axis is in what? Minutes. It might be worth your time before you start the question to convert all the minutes to what? Hours, or at least the values that you plan to use. And you know how to convert what? Minutes to hours. You just simply divide by 60. So instead of 20 minutes before you start the question, you should probably take 20 and divide it by 60. That is just my advice. And also, if you take the 20 and you divide it by 60 and you get a reoccurring decimal, remember the advice I gave you? Use the fraction instead. The examiner will appreciate that. Good luck and send the answer on the chat. Make sure you see it in the notes, right? In a distance time graph, to find the speed, are we required to find the gradient? Look back in your notes and I want you to physically see that note from last week. Whenever we're doing distance time graphs, the speed is represented by the gradient. Just so tell me, yes, sir. Flip back in your notes and physically see it, right? It actually helps you a little bit, right? Great. And of course, so in a distance time graph, the speed is represented by the gradient of the line. Well, only for a distance time graph. And how do you find gradient? If you look back in the notes, you even see the formula for gradient. y2 minus y1 divided by x2 minus x1. So they ask us for the speed between A and B. So we should get the coordinates first. I'm going to do something slightly wrong first. The coordinates of A, well, that's the origin. That's 0, 0. And for B, the coordinates is what? The x coordinate is 20. And the y coordinate is 6. Does everyone agree with that at least, right? And when you have something slightly wrong, but it's not a great mathematical offense as yet. Remember, you just always put the x coordinate first and then the y coordinate. X comes before y. Now, if I want my speed to be measured in kilometers per hour, I need to make sure that my time values are in hours. I can't have it in minutes. And you notice the examiner gave you what? The time in minutes. So this 20 here, that's really 20 minutes. But we know how to convert minutes to hours, right? We just have to, I'll do the working somewhere on top here. All I have to do is take the 20 and divide it by 60. Now, when you reduce that, you will get 1/3 or 0.333333. I prefer if you use the 1/3 because I know some examiners can be very, very picky about using fractions in place of reoccurring decimals. We're good so far, guys? Everything good so far? Right, so a lot of people are saying yes. So let's get the values. A is x1 and y1. Remember, for 2 points, choose any point first. You could choose A or you could choose what? B. I like to go in alphabetical order, so I will choose A first. So A will be x1 and y1. B will be what? X2 and y2. So let's throw it into this formula here. Y2 is 6. Y1 is 0. X2 is 1/3 minus X1 is 0. So this should be easy to do, right, in our heads, right? But we'll do it here. That's how. 6 minus 0 is 6. 1/3 minus 0 is 1/3. 6 divided by 1/3 is 18. And our answer will be in kilometers per hour because we used the kilometers and we converted the minutes to hours before we did the calculation, right? So it's 8. And if you don't believe me, that's 6. Let me show you. 6 divided by 1/3. 6 and 6 divided by 1/3. You can write it like this instead. But remember in primary school, when you change the divide to multiply, you just flip the fraction after. So 6 by 3 is 18. For those who are sending the wrong answer across still, you saw the mistake? 6 divided by 1/3 is 18. If you don't trust me, you can throw it in on a calculator and you would see that it's 18, right? But make sure you resolve your error before we move on, right? All right, same graph. Another question. What is the speed of the object in meters per second? All right, there are plenty different ways of doing this question. You all can decide. Now, the speed, they ask for the speed between C and D. So I'll show you all 2 ways we can actually do that question. Just remember, minutes is not really what we just use to measure time in CXC. When it comes to measuring speed, it's either the time have to be in hours or it have to be in seconds. Nobody does really use minutes, okay? Good luck, and I'll give you a couple of minutes. Remember, they want the answer in meters per second. So what we could do, we could get the answer in kilometers per hour. And remember last week, I showed you all, once we get the answer in kilometers per hour, there is a formula to convert it to what? Meters per second. I just write in the back. I know it's in your books, but the formula to convert kilometers per hour to meters per second is to multiply it by 1,000 and then divided by 3,600. So if we plan to first get our answer in kilometers per hour, we have to make sure our distance is in kilometers, which it is, and our time in what? Hours, which it is not at the moment. But that is okay. Let's convert it here. Let's get the points at least. Point C is 100 minutes on the x-axis. And how much is it on the y-axis? 6 kilometers. D, it's 120 minutes on the x-axis and 8 on the y-axis. Now, don't get me wrong. The 6 and the 8 are good because those are kilometer values. So that's safe. But the 100 and 120 are in minutes. So what we have to do, we have to divide both of them by what? 6 there. I think we all in agreement with that, right? So if I take 120 and I divide it by 60, we're going to get how much? 2 hours. 100 divided by 60, I cannot do that in my head, so let me do that in a calculator. Anybody got 1 and 2/3? When you take 100 and divide it by 60, you got 1 and 2/3. Right. You'll see 1.66666666, which is 1 and 2/3, right? Make sure you see it on your calculator. Right, which is great because now all our values are kilometers and hours. So if I decide to find the gradient now, which represents the speed in a distance time graph, my speed will come out in what? Kilometers per hour. So let's go ahead and find the speed, which is represented by the gradient of a distance time graph. So it's y2 minus y1 divided by x2 minus x1. The first point, call it x1 and y1. Next point, call it x2 and y2. Y2 is 8, y1 is 6. X2 is 2, x1 is 1 and 2/3. Don't let the fractions get to it. You can just use your primary school knowledge here to get this out. 8 minus 6 is 2. If I have 2/3 of a cake and somebody steals 1 and 2/3, and you'll be left with 1/3. 2 divided by 1/3, if you don't believe me, is 6, and the answer will come out in kilometers per hour. Remember, 2 divided by 1/3. Divide will change to a multiply, and it will flip. 2 by 3 is 6. Right? Remember how we got the 2 over here? It's 120 divided by 60 because we converted the minutes to hours. And how did we get the 1 and 2/3 here? We took the 100 minutes and divided it by 60. So the answer was 6 kilometers per hour. Right? Now, guys, okay, we gotta stop asking this, right? Right. So we need to convert this to meters per second, right? I sounded like this was planned. I actually forgot I had to convert it to meters per second, right? I really did, and I'm playing it off cool, but I did forget. All right. To convert kilometers per hour to meters per second, we said we would multiply it by 1,000 and then divide it by how much? 3,600. And running out of space over here, right? So let's do that. And then our answer will come out in what? Meters per second. 6 multiplied by 1,000 divided by 3,600. I get in 1 and 2/3, or 1.66666666, which is the same thing as 1 and 2/3. Right? So let's start back from the beginning here. Right? I'll leave any working on the end here. Right. So let's get the points. Now, the thing about it, if we want our answer in meters per second, then we should make sure all our distances are in meters, and make sure all our time is in what? Seconds. So how do you convert kilometers to meters? You multiply it by 1,000. How do you convert minutes to seconds? You multiply it by what? 60, because it has 60 seconds in a minute. So let me write it a little bit bigger here first, and then we could. The time here is 100 minutes, right? And the distance here is 6 kilometers. Now, right now it's in the wrong units, right? Over here, the time is in what? Minutes, which is 120, and it have what? 8 kilometers here. The kilometers is pretty easy to convert, right? I think everyone could convert what? Kilometers. The meters, we just have to multiply by how much? 1,000. 1, 2, 3. The 6 kilometers multiplied by 1,000. You'll get what? 6,000. How do you convert minutes to what? Seconds. You have to multiply him by 60. And this 100 minutes, you also multiply by 60. So if we do that now, you're going to realize everything will be in kilometers and what? Seconds. So let's do that. 120 by 60 is 7,200, and 100 by 60 is 6,000. So I just put any units on top now. This is in kilometers, this is in seconds. This is in kilometers, this is in seconds. Call this one X1, this one Y1, this one X2, and this one Y2. Throw it into the gradient formula and let me know if you get the same answer at the end of the day. 1 and 2/3. Sorry, I made a small mistake. Huh? The distance is in meters, not kilometers, because we multiplied it by 1,000. Work it out and see if we get the 1 and 2/3 straight. Remember, it's y2 minus y1. I think some people are mixing up the values, right? I have it written here. Which one is y2 and which one is y1? So it's 8,000 minus 6,000. Those are the big values get to you. Your calculators can handle the large values. X2 is 7,200 and X1 is 6,000. 8,000 minus 6,000 is 2,000. 7,200 minus 6,000 is 1,200. And 2 zeros were cancelled out with 2 zeros here. You'll end up with 20 divided by 12. Now, I guarantee you, if you take 20 and divide it by 12 on the calculator, I see in the same 1.66666666666, which is 1 and 2/3 meters per second. Check it back. The working is on the screen. If you got it wrong, just follow my working and you should be able, to pinpoint what you did wrong. All right. Let's see what's next. Which object has the higher average speed? Right? Keywords, average speed. Now, I know some of you cannot, for the blue graph, you might not be able to see the X value. But keep in mind, it falling directly in between the 100 and 120. Remember, speed and average speed is two totally different things. Also, I know the Y value here is kind of hard to see, but I'm letting you know it's 9. Okay? That's for this Y value here. So I'm letting you know it's 9. Everything else should be readable. Once again, speed and average speed is two completely different things. Look back in your notes and see if we can resolve what the difference is. All right. So remember, the main antagonist of the story is Scarlet Bloodwind, and she was controlling the red dragon from last week that was attacking them. All right, so hopefully they'll reach the Bay of Monsters. This here is the Bay of Monsters. That there, guys, is the Kragmat. All right. All right, so the Kragmat says that he has found the crystal and has saved it for them. Suspicious behavior. Getting the Kragmat actually did that he actually found a beast crystal and was so nice enough to capture it and hold it for them until they came. Or you think he up to something. Right? I think he up to something. Anyway. Right, so yeah, they seem to trust him. I would trust him too. All right, guys. So here we have a slightly different type of graph. Look at it. It's no longer distance time graphs. It's speed time graphs. I want you all to go back to your notes from last week. How are speed time graphs different? What does the gradient tell you? And what does the area underneath the graph tell you? Tells you. It's completely different information that can be well gotten from a speed time graph rather than the boring ones we were doing before, the distance time graphs. Right? So using that information, what is the acceleration between A and B? As you all remember, well, not remember, you can see clearly in your notes. Acceleration is represented by gradient in a distance time graph. Also, acceleration, well, if your speed is in meters per second, which it is, and if your time is in seconds, the units will come out. If you look back in your notes, it will be in meters per second squared. I gave you all a little table last week. So calculate the gradient and make sure you send the answer with the correct units. Meters per second squared. So just finding gradient as usual. A is 0, 0. B is 28. 20 on the X, 8 on the Y. Okay. So X1, Y1. X2, Y2. Right? I think everyone getting the hang of finding gradient now, right? So in a speed time graph, acceleration, right? Gradient. Y2 minus Y1, 8 minus 0. X2 minus X1, 20 minus 0. 8 over 20, I think we're going to get a decimal, right? Some people have it wrong side. Remember, the 8 ends up on top and the 20 ends up underneath. 8 divided by 20, we got a real nice decimal, so I'll use the decimal. 0.4 meters per second squared. All right, so making sure it's correct. Yeah. 0.4. Look for your mistakes. Look for your mistakes. Shouldn't be too hard to spot your mistake. What is this asking? What is the acceleration between B and C? All right. Well, some of yours the shortcut to this question, right? You shouldn't waste time on a simple question like this. I showed you all a way around this, a shortcut. It's another acceleration question, right? And acceleration, well, to find acceleration on a speed time graph, you need to find what? The gradient. But remember last week I told you all that a flat line will always have a gradient of how much? 0, right? So there's no need to do any work. I mean, you can go and do the calculations, but I guarantee you, you're going to get 0. So don't waste your time in like that for the exam. So the acceleration between B and C, which is what the question is asking, is 0 meters per second squared. Right? There's no need to do any working. Keep in mind, a flat line will always have an acceleration of 0, a gradient of 0. Quick question. If something has an acceleration of 0, does that mean it has stopped moving? Like it's a stationary object? Well, what are your thoughts on that? The answer is no, right? Something can have an acceleration of 0 and still moving. And I can prove that from the graph, you can see that. Between B and C, the acceleration is 0. But how much is the speed? It still has a speed of 8. Acceleration allows you to speed up or to slow down. An acceleration of 0 doesn't necessarily mean the object has stopped. It's just moving at a constant speed. The speed is not changing, but it's moving, but just the speed is not getting larger, nor is it getting what? Smaller. It's like that. If you're on the highway and you're moving at exactly 100 kilometers per hour, which is the speed limit, and your foot doesn't move off the X, so you don't move faster or slower, right? So don't ever fall for that trick, right? An acceleration of 0 does not necessarily mean that you have stopped. Great. Let's move on. What is the acceleration between C and D? Well, it's another gradient question. You just need to get the coordinates of C and D correct. Let's see who is right. Remember, we find ingredient as usual again, right? Y2 minus Y1 divided by X2 minus X1. Let's throw it in. Call the first one X1 and Y1. Next one is X2 and Y2. All right, so it's 10 minus 8 and then 70 minus 40. I think we're getting 2 over 30, which is 1 over 15 meters per second squared. Right, check it back. It's definitely not 2/3. It's 1 over 15. Let's see what this question. Now they're asking for the total distance traveled. Now, this is almost like a primary school or Form 1 question, right? You have to find the area underneath the shape, but you want to break it up into different shapes, right? It have 4 different shapes here. 2 rectangles and 2 triangles. I'll call this shape A, B, C, and D. Find the area of each shape and add them up. I'm going to give you a full 10 minutes. I'll drop in some hints, obviously, right? Remember how to find the area of a triangle? We did it not too long ago. Base by height divided by 2. Right. For the triangle from here to here would be 20. And the height would be what? 8. Let me get a different color. I shouldn't write red on red. Right? Because from here to here is 8, right? And this is 20. Because here's 0 and here's 20. From 20 to 40 is another 20. And the height is still what? 8. From 40 to 70. Remember, if you start at 40 and you move to 70, that's 30. And from here to here is still 8. I mean, from this point here. Now, if here is 30, then the opposite side is also 30. And how much is from here to here? If here's 8 and here's 10, 8 to 10 is how much? 2. How much people were using the correct measurements? Now it's just to find the area of each part and add it up. For the triangle, for A, it's base by height divided by 2. So base by height divided by 2, that will give me 80 meters. That's the distance for portion A. B is a rectangle, length by breadth. 20 by 8 is 160. C is also a rectangle, length by breadth. 30 by 8 is 240. Guys, some of you are getting the units wrong. They're asking you to calculate the distance. Isn't distance measured in regular boring meters? Some people put in meters per second squared. That's a measurement of acceleration. This is distance. Now for D, base by height divided by 2. Base by height, and this will give me 30. Add up all 4 and let me know what you will get. So let me see. 80 plus 160 plus 240 plus 30. I'm getting 510. I'll put in the answer here. Check it back, guys. You made a mistake somewhere. But some people, not everybody. All right, so no one suppose, well, this question asks you for the average speed. Remember the formula for average speed? Average speed is the total distance over the total time. I'll give you a hint. You will need the answer from the previous part, the question, the part we just did. Didn't that part give us the total distance? And we now worked hard to get the total distance. So how do you find out? I'll put the average speed, right? Average speed is what? Total distance over total what? Time. So I think I gave you too much hints there. So no one is supposed to get it wrong from this point. Remember from the last part, the total distance was 510 meters, right? Remember when we found the area underneath the entire graph, the area represented the distance. And how long did it take to do this? What time is this? 70 seconds. Right, I know some of you said we're going to get a decimal, no problem. 510 divided by 70 is 7.28 meters per second. Because speed is measured in meters per second. If you have it as a fraction, that's 510, that's 510, right? Or some people put 7 and 2/7 meters per second. Any one is correct, right? But look for your mistakes. And guys, some people are saying it's 0.14. It's not that. The 510 goes on top. The 70 goes underneath. Right? Remember, the 510 came from the previous part. Didn't the last didn't the last part we now did when we found the area underneath the graph, remember a few minutes ago, we got the total distance to be 510 meters. When we found the area underneath the graph, the area underneath a speed time graph gives us the distance. And we actually did that a few minutes ago. So like I say, what is it we're looking for? You're using that answer now to help you with this particular question. Let's see what's going on here. How much minutes did the object move at a constant speed? All right. Oh, this is a brand new graph. This is a brand new graph. Now, look at the x-axis here, right? The x-axis, they gave you the time like on a clock, right? When you're telling time now, 8 o'clock, 8:30, and whatnot. So let's give it a try. This is I want to believe that this is actually a primary school a SCA question, and of course it comes back in CXA. Constant speed, that would be the flat part of the graph, right? Constant speed means the speed is not changing. The acceleration is 0, which means the flat part of the graph. Let's see. You notice over here is 10:30 and here's 11, right? So here's 10:30 and here's 11 o'clock. The flat part starts here. Isn't this 10:45 a.m.? And of course, part C here is in between 11:30 and 12, right? So directly in between will be what? 11:45. For those who couldn't see it, you think you understand it now? So the flat part starts at 10:45 and ends at 11:45. If you supposed to meet somebody for 10:45 and they come 11:45, how long they keep you waiting for? They keep you waiting for a whole hour, right? But they ask you for minutes now. If you read the question, they want it in minutes. So it's 1 hour. But we know 1 hour is what? 60 minutes. So they keep you waiting for 60 minutes. So I find this question was pretty easy, but once you realize you gotta change your mindset now. The x-axis, not just in minutes, it's telling time like a clock now. For those who got it wrong, you think you understood it now? Let me know now, because quite a few people got it wrong. Like literally half the answers were wrong. All right, let's move on. All right. Let's see what's going on here. Well, they go into the cave hoping to see the crystal, right? And there's the Krogmat in the background there. And they move the rock and they don't see a crystal. No surprise there. So apparently the monster just took some lettuce and he painted it blue to trick them, right? And that's the Krogmati. After he comes into the cave and traps them in the cave there, things don't look too good there. All right. Right, so they have to fight or run or do something, right? So Jibby does what Jibby does. He attacks the monster there. Right, you can read the action there. Right, and a strange witch appears to help them out. Some real action there for you guys. All right, so we'll see what happens there. All right, how about this one here? What is the total distance moved between A and B in kilometers? Now check, this is actually an easier question than you think, right? The speed is in kilometers per hour. Make sure when you're calculating the times, you also use hours. How do you find the distance in a speed time graph? Well, that's easy. You find the area underneath the graph. So you break it up into two shapes, shape A and shape B. Remember, over here is how much? 10:45, and over here is what? 11:45. Make sure when you're, once again, when you're reading off the times, read it off in hours. So it's two shapes you have to find the area of. Find the area of both of them and add them up. And that will give you the distance in kilometers. Look at the base here of the triangle. If here is 10 o'clock and it ends at 10:45, right? Isn't that 45 minutes? Isn't that 3/4 of an hour? Isn't from 10 a.m. to 10:45? That's 3/4 of an hour. I'll make some space there. So this is 10:45. Over here, that's now, yes. And here's 11:45, right? And how much is the height? The height is 6. Because the height is 6 here, right? So for the triangle, is base by height divided by 2. Base by height divided by 2. And for B, well, when we establish from 10:45 to 11:45 is 1 hour. So length and the breadth is 6. Length by breadth. Work out both of them and add it. Once again, from 10 to 10:45 is 3/4 of an hour. We want the time to be in hours to match the speed. Remember, if the speed is in kilometers per hour, you want your time to be in hours as well. Right? If you don't like the 3/4, you can just replace it with 0.75. I got 2.25 here, kilometers. And 1 by 6 is 6. I'm just making sure. So when you add it, how much you'll get? 8.25 kilometers. Make sure you see it, and just a copy down my answers. Make sure you physically see it on your calculator. One person corrected me. Did you all realize what I did wrong? They asked me for the distance between A and B. I found for the whole graph, it was only supposed to be for A. Sorry, so I found the second part by mistake. Everyone saw the mistake there? It's a slight mistake, right? They only ask us for the area of the first part of the graph, the triangle. They didn't ask us for the rectangular part. All right, so thanks for that clarification.